Alright, we have something different on this one now. Again, we have a period change and a phase change, but now we have a change in our maximums and minimums. Now the maximums and minimums are affected by the amplitude, which you guys have already seen, but now we have a shift, and so we're going to have to take the amplitude and the shift to figure out our maximums and our minimums. Okay, so let's get started. Now I like to see, let's go ahead and start off in black. We have y equals 3 sine. I like to take the b out. I don't like the b to be right next to the x inside of the parentheses because it messes with stuff. And so if I divide the first one, 2x by 2, I get x. Now I have to divide the pi over 2 by 2. Let me write this out just so I don't miss or lose anybody. If I divide this by 2, that's the same as saying pi over 2 times 1/2, times the reciprocal. So we get 1/4, and it's minus. So I get, wait, 1/4? No, pi over 4. Okay, so pi over 4. And then we have our minus 1. Chillin'. Okay, let's see here. Let's do the amplitude first. That's 3. My period is going to be 2 pi divided by 2, which is just pi. So let me write that out. 2 pi divided by b, which is 2, which equals pi. Alright, that's done. Now my phase shift is going to be, let's see, it says minus pi over 4, so that means it's going to be positive pi over 4. Our maximums, well, normally it would just be 3 and negative 3, but this time we have a plus 1. So before we would think, oh, it's 3 negative 3, but, I'm sorry, minus 1. But now we have a minus 1, so the whole thing shifts down. So it's not going to be 3 anymore, it's going to be 2. It's not going to be negative 3 anymore, it's going to be 4. You just have to subtract 1 from each of those, no problem. Our X and Y intercepts, let's do those last. Ooh, did I forget those the last video? I don't remember. Oops. Oh well. Alright, let's do our X values first. I'm not going to worry about the maximums and minimums quite yet. I actually worry about that normally when I get to the scaled graph. I think the hardest part is finding all your X values. So let's start with that. Our sine function normally looks like this. Oh, that's horrible. Okay, like that. Okay, we normally start at 0, but wait. We have a phase shift. It's a phase shift of positive pi over 4. So that means our first X value is not going to be 0. It's going to be pi over 4. And then our period is pi. So to know what we're going to increase by each time, let's take the period, which, the whole length is going to be pi. Let's take it and divide it by 4. So we have pi divided by 4. Ooh, it's pi over 4. So I increase by pi over 4 each time I go to my next x value. So let's increase by pi over 4. Pi over 4 plus pi over 4 is going to be 2 pi over 4, which simplifies to pi over 2. And then if I add pi over 4 again, I'm going to get 3 pi over 4. If I add pi over 4 again, I'm going to get 4 pi over 4. Oh yeah, that simplifies down to pi. And then if I add pi over 4 again, I'm going to get 5 pi over 4. We're adding fractions here, so every time I say add pi over 4, you actually take whatever this is and add pi over 4. You have to find common denominators and all this stuff, and that's how you'll get 5 pi over 4. Okay, now let's look at our amplitude. Our amplitude is not negative, so I don't have to worry about flipping it. I just know that it goes up to 3. My first value is always at the midline, and then it goes up to 3, and then we'll go back to the midline, then down to 3 for our minimum, and then back up to the midline. And so this is what my graph looks like. Okay, now let's see what it looks like on a scaled version. We can see if it scrunches or stretches or what have you. I'm just going to graph the point straight up here. This is pi over 4, and it goes to 0. So pi over 4 will be right in the middle of 0 and pi over 2. So this is my first point. My next point is at pi over 2, and that goes up to 3. So I put a dot right there. My next point is at 3 pi over 4, which is right here. Actually, let's use black right there, and then we'll make the point with red. Oh. And then the next one's at pi, and then we go down to 3, so right there, and then the next one's going to be right in the middle of pi and 3 pi over 2. And so this is my graph right now. We can now just extend it, okay? So each time, so we increase by pi over 4, we're going to get to 3 pi over 2, which would take me up to my maximum. And then we go pi over 4 again, so we go to right there. There's my X-intercept. and then we go down to here, and ooh, you know what I just noticed? We forgot something. What did we forget? Right now, our maximums are 3 and -3, which is not true. It's 2. It's supposed to be 2 and -4. Ooh, mistake. But the mistake is good. Because you can see how we find the x values, which is the most important part, because I think it's the hardest part. Now we just have to take this whole graph and shift it down. And you might have already seen that, and you wouldn't, maybe you didn't graph it like this. So here, let me erase this and regraph it. Alright, let's see. Let's do this again. Okay, so let's say you remembered, and didn't forget like I did, that there's a -1, so it goes down. Down 1. So if you wanted to, I guess, you could say, oh yeah, this is not 0 anymore. This is going to be -1. And so I have a midline at -1. There's my midline. What's up, midline? Midline goes down. You are no longer the x-axis. Okay. So let's go back to all our points again. Let's go ahead and use black. Okay, so we're going to start right there because that's what it's... Ooh, no, we're not going to start right there. We're going to start right there because it's supposed to start at pi over 4s. And that's pi over 4 because that's right in between 0 and pi over 2. Then when I get to pi over 2, I go up to 2. Oh, that's right, the maximum point. Okay, and then I go back down to the midline right there. And that's at 3 pi over 4. Down to midline, and then at pi we go down to, ooh, not 3, to -4, and so we go down there, and then we go back up to the midline, which would be, you know, I'm just looking at between these. That's my next x value, so that's how I knew the point goes right there. And then at 3 pi over 2, we're going to go up to the 2, and back down the midline, down to the -4, and we got our graph going on right here. Let's see. Yeah, see, that's normal sine. That's what we have right here, and we continued it because our window was bigger, and that's what it looks like. Okay, let's put this down here. All right, that's how you graph that guy. That one has all the business happening to it. The period changes, we have a phase shift, the amplitude changes, and we have a vertical shift. So we have a lot of gnarly stuff happening there. Look at this guy down there. He's going to get done next. Here we go. Alright, I like to rewrite this guy so that I take the b off of the x. So cosine, then we have pi over 2, and then we have x, and then, oh sorry, I clear my throat so much on this thing. And I know that's really annoying, sorry guys. I took out a pi over 2, and when I take a pi over 2 over this one, pi over 2 divided by pi over 2 is just 1. So we have 1x, no problem. Now we have to go pi divided by pi over 2. So I'm going to write this one out. And that would be the same as going pi times 2 over pi, the reciprocal. And the pi's cancel out, and I'm left with 2. Yay! Okay, so this is a 2. Plus 2. Alright, and then we have a plus 3. Ooh. Alright, so let's see what everything looks like here. We have the amplitude, which is 1 still. We don't say negative. The amplitude is the distance between the midline and the maximum point, or the minimum point. Or you can say it's the distance between the maximum point and the minimum point divided by 2. Our period, the period, let's see, normally it's 2 pi, but I have to divide it by the b, which is pi over 2, which is the same as saying 2 pi times 2 over pi. Oh, lots of canceling going on here. Oh, it's 4. Alright, that's kind of neat. So our period is 4. Our phase shift, we already did the work for that one. It's -2. Remember how you always think the opposite. And our maximums, our minimums, those are going to change. See, normally you would just say it's 3 and -3. However, we're adding 3 to our graph. And so that means our maximum is not going to be 3, it's going to be 6. Our minimum is going to be 0. This is going to be 6, this is going to be 0. All I did was add 3 because the whole graph shifts up 3. And now we have our y-intercepts and our x-intercepts. Oh, and I think I forgot to do that on my last graph too. Stink. Alright, here's the previous graph, number 7. Alright, to find our x-intercepts, that's going to be kind of difficult. Our y-intercept's not bad. Our y-intercept's pretty simple. It's down to -4. So I put a -4 right here. But our x-intercept's not so pretty. We know what this point is, what this x value is, but we don't quite know what that one is. In order to find that x-intercept, you're going to have to take this function and set it equal to 0. So it would say 0 equals 3 sine 2x minus pi over 2 minus 1. And you have to solve this. We don't have time to solve this. And so I'm going to say you don't have to worry about the x-intercepts for this right now, because right now we're just really looking at graphs. We can do this, okay, but that's next unit. Oy, I know I've reached the 10-minute mark, but hang with me. So this is the normal cosine graph. It would just go like this. Nothing fancy. Oh, but wait a second. This one flips. The period, or the amplitude is 1, but we do have to flip this bad boy. So let's flip him. So we're going to start at -1, go up to there, go up to there, go up to there, go up to there. Now I know that's not going to be -1 right here in the future, because I know my minimum is not -1. It's actually 0. But I'm not going to worry about that right now. Let's finish graphing this first without the vertical shifts. Okay, normally we start at the x equals 0. But we have a phase shift of left 2, so we're going to say that this is -2. Now what are we going to count by to get our other x values? We're going to count by, let's see, the period is 4. Ooh, 4 divided by 4 is 1. We're just going to count by 1s. Ooh, that's nice and convenient. We have -1, 0, and then 1, and then 2. Alright. Now we're counting by 1s here. We're not counting by pi over 2, so we're going to have to do our business over here to try to make this scaled the way we want it to be scaled. Now I kind of discussed this earlier, so I'm going to kind of fly through this. And this would be about 3, because pi is 3.14. This would be about, right here, that would be about 6, because 2 pi is 6.28. And then we have the middle, which would be 1.5. But we don't want 1.5. We want 1 and we want 2. So it's 1, 2, and that would be about 4, and that would be about 5. And now we have something that would work with our scale right here. Alright, so let's put this graph over here. This part in the negatives we're not going to see over here because we start with 0. So 0 goes up to not 1. Well, we know this is the maximum value right here. What's our maximum value? The maximum value is 6. And so at 0 we're going to go up to 6. So it says 1, 2, 3, 4, 5, 6. Oh, we're off the graph, boo. So we're going to put our first point right there. At 1 we're going to go to the midline. Now the midline used to be 0. What's our midline now? It used to be 0. Oh yeah, we shifted up 3, and so our midline is going to be at 3. And so I'm going to go over to 3, and I'm going to draw this dotted line thing. You'll like this dotted line thing, this midline, because it helps you find all the other points. At 1, we're at the midline, so we go right there to midline. At 2, we're down to 0. Ooh, that's a nice x-intercept. See, right there? Oh no, I'm sorry, right there. At 3, we're back at the midline. At 4, we're at the maximum. At 5, we're back at the midline. And at 6, we're back down to the axis. There you have your graph. Alright, that looks good. Alright, I'm not going to forget this time. X-intercepts are 2 and 6. And let's see, the y-intercept is at 6. That's how you do it.